Hello everyone. Today we are starting a new segment and this is the segment of ozone layer depletion. Now when we talk about ozone layer depletion, this is one topic that always remains in news. There will be new scientific research that will happen. There will be new data that will surface. And because of all this research and the data that surfaces all the time, because of this very reason, you'll see that this is one topic that always remains relevant. Now, because of this particular reason, this is also a topic that remains very important for your examination as well. Both the prelims as well as mains examination. There have been questions in the past that have been asked from here, and there are high chances that a question can come in the upcoming prelims and mains also. So you have to understand this topic well, and all the aspects, whether from science perspective, whether from the impact perspective, all this remains very important. So let's start with the topic. And to begin with, before going into the topic of ozone layer depletion, we need to understand what is the meaning of ozone. So when you see this particular word, ozone, what do we mean? In very simple terms, it just means a form of oxygen that has 3 atoms. So basically we are saying that this is triatomic. What is the meaning of triatomic? Tri means 3, atomic means containing atoms. So any molecule of ozone contains 3 atoms of oxygen. When you talk about the normal oxygen is diatomic, meaning that it has 2 atoms of oxygen. Now this is where all the discussions start from, because to understand why ozone has so much of importance, you need to understand the chemistry of ozone, and very briefly we'll deal with it. So in general, talking about the structure of atom, for any atom to be stable, it will need 8 electrons in its outermost shell. What is the meaning of outermost shell? You know that if you talk about an atom, there is a nucleus centrally placed which has the neutrons and the protons, and then there are electrons which are revolving around this particular nucleus in various shells or various orbits. So the outermost orbit that you have, the outermost shell that you have, it should have 8 electrons so that the atom is stable. If it is a smaller element, in that case the atom should have 2 electrons in the outermost shell. For example, in case of helium and hydrogen, this is what holds true. But for bigger atoms, this is what is required, that the outermost shell should have 8 electrons. Now what happens with oxygen? Oxygen has 6 electrons in the outermost shell. So if you talk about the structure of oxygen, you have 2 atoms. Now these 2 atoms have electrons revolving around them. Now these 2 oxygen atoms have 6 electrons in the outermost shell, right? So what do they need? They need 2 extra electrons. How will the 2 extra electrons come? From the second atom. So what we'll see is that there will be a sharing of electrons that will happen. So now if you look at the first atom now has completed its octet, meaning that it has now 8 electrons in the outermost shell because 2 has been borrowed from the second atom. Similarly for this atom as well, the second atom as well, you can see that it has 1, 2, 3, 4, 5, 6 already, and 2 more have been borrowed from the first atom. And because of this borrowing, now this second atom also has 8 electrons in the outermost shell, and because of this now also has become stable. So this is what happens with a normal oxygen molecule. Now with ozone, the things are a little different. What happens with ozone is that there are 3 atoms. And because there are 3 atoms, there is an added complication. There is an added instability. So what will happen is that there will be one bond which will be formed between the first 2 and a single bond which will be formed from the next. But there will be a charge distribution that will happen. Just see this, that what will happen is that there will be a charge distribution because this sharing that will happen is unstable. So there will be 2 forms, either this charge will be on this particular atom or the other one. So either this will be negatively charged or this will be negatively charged, and this central one remains positively charged. So because of this, what happens is this is an unstable molecule. Now since it is an unstable molecule, it will always try to attain stability. It will always try to attain the structure that a normal oxygen has. So what will happen here? All this ozone will always try to convert to oxygen, and the very first chance that it gets to convert into oxygen, it will take that. And this is where the complications start, and that is the reason why you will see that this ozone will always be very highly reactive. It will react with anything that comes into its way, and by reacting it will try to form something which is more stable, and by doing that there will be a depletion of ozone that will happen. So when we talk about ozone layer depletion, first of all, what we know is that ozone is a gas that is present naturally within the Earth's atmosphere. It is formed of 3 oxygen atoms, as we discussed. The ozone layer can be depleted and broken down through its interaction with man-made compounds in the upper atmosphere. Now, why this interaction is happening? This interaction is happening because ozone is unstable. So what ozone will always try is that it converts into oxygen. And if you go back to how to balance the two sides, you know that you can balance like this, correct? So this also has 6 atoms and this also has 6 atoms of oxygen now, right? So this is a balanced equation. Now what is happening is that this ozone will always try to convert into oxygen. Now this can happen in various ways. For example, we discussed about the man-made compounds, and these man-made compounds, when emitted into the atmosphere, they go and react with ozone, and by reacting with ozone they reduce ozone to oxygen. So what happens here is you can see something like this. Now when we talk about chlorine, chlorine is also something which will come from chlorofluorocarbons. What are chlorofluorocarbons? We'll come to it, but it is a kind of chlorofluorocarbon. Now chlorofluorocarbon obviously has chlorine. Chloro comes from there. So this chlorine will react with ozone to form chlorine monoxide, and oxygen molecule will be given out. In the second step, again what will happen is this still is not stable enough. So what will happen is that this oxygen and this oxygen will combine and form another oxygen, and ultimately we see that chlorine and oxygen are formed here. So chlorine gas and oxygen gas. So ultimately what is happening is that one molecule of ozone is coming in contact with another atom of oxygen, and ultimately it is forming oxygen molecules. So ozone now has been reduced to oxygen molecules, and this is what it will always try, because as we discussed, the structure of ozone is unstable. It will always try to gain stability. There should not be any formal charge on any of the atoms for it to remain stable, and that is the whole reason of why this will happen. So ozone destruction mechanism is something like this. So whenever it comes in contact with any of these kind of compounds which have chlorine or fluorine, etc., it will always react with ozone, and by reacting with ozone it will deplete ozone. It will convert ozone into oxygen, and that is the whole reason behind ozone layer depletion. Now when we talk about ozone, ozone is present in 2 different layers of our atmosphere. One in the very lower part of the atmosphere, that is troposphere, and it is also present in the stratosphere. The discussion that we are doing here is the stratospheric ozone, right? So this is the ozone which is present in the stratosphere, and there is another ozone which is present in the troposphere. Now what happens is, you'll see that generally when we talk about troposphere and the ozone in the troposphere, it is something which is also called as bad ozone, and the ozone that is present in the stratosphere, it is also called as good ozone. Now how come the same ozone becomes good in stratosphere and becomes bad in troposphere? In case of troposphere, that is the lowest level of the atmosphere, it acts as an air pollutant. And since it is an air pollutant, that is the whole and sole reason why it is called as bad ozone. And we have had a discussion on this. So just remember that tropospheric ozone is called as bad ozone and stratospheric ozone is called as good ozone. Why good ozone here? Because this is ozone which is basically helping you counter the ultraviolet rays of the sun. this layer of ozone is able to protect us from the ultraviolet rays of the sun, and because of ozone layer that is there in the atmosphere, the harmful ultraviolet rays do not reach the surface of the earth. So that is the whole reason why we call it as good ozone. So the same ozone, when it is in the lowest part of the atmosphere, it is called as bad ozone because it acts as an air pollutant, and the same ozone when it is in the stratosphere, it acts as a good ozone because it helps us protect from ultraviolet rays of the sun. Now let's try and understand the causes of ozone layer depletion. Now talking about the ozone layer depletion, first of all, the ozone layer depletion is happening because there is the conversion of ozone into oxygen, and that's why a depletion of ozone layer is happening. Now, when we talk about this ozone layer depletion, there are certain causes, and behind all these causes that we are going to discuss is the basic chemistry that we just discussed, that ozone is unstable, it will always try to convert into oxygen, and if it gets any catalyst that helps it in converting into oxygen, it will take the help of the same and convert into oxygen. Now, the first help that comes here is in the form of chlorofluorocarbons. Now, chlorofluorocarbons, these are a set of compounds which basically were for the first time discovered in 1930s by one of the chemists at General Motors. Now, when he discovered this and all the research and development that happened with respect to chlorofluorocarbons, we saw astonishing properties: odorless, colorless, non-corrosive, non-reactive. All these look to be very good. And also it was found that these are the chemicals that can be used in air conditioners, it can be used in refrigerators, and in all these components, all these electronic and electrical components, it could be used. So at that point of time, chlorofluorocarbons look to be some wonder chemicals. But then at that point of time, we never realized that what could happen because they are non-reactive. We are saying that it is non-reactive, non-corrosive, colorless, and odorless gas. So we are talking about the chlorofluorocarbons. Now these chlorofluorocarbons, non-reactive, non-corrosive, colorless, odorless. So these were properties that looked to be very good for a compound to have, and because they had applications in air conditioners, in refrigerators, etc., these looked to be wonder chemicals at that point of time. We never knew about the ill effects that it can have in the upper layer of the atmosphere. Now that they are non-reactive, because they are non-reactive, they can remain in the atmosphere for a very long time. So they started to go into the upper layer of the atmosphere, that is stratosphere. Now after this, they started to get deposited in the stratosphere. What happens next is something that the scientists never thought of. These chlorofluorocarbons, because of the ultraviolet rays that are coming from the sun, because of the action of these ultraviolet rays, these break down. And because of this particular breakdown that happens of chlorofluorocarbons, they release chlorine. And now that they release chlorine, this chlorine is something that will now go and react with ozone. We had seen the reaction of ozone with chlorine. Now because of this reaction that is happening between ozone and chlorine, the conversion of ozone into oxygen will start now. So what was observed in 1970s for the first time is that ozone layer is depleting, that there is a lot of conversion of ozone into oxygen that is happening in the stratosphere. And when the scientists started to look for the reasons why it could be happening is when they saw the action of chlorofluorocarbons. And in 1970s, 1980s, chlorofluorocarbons were widely used. All the refrigerators, all the air conditioners, aerosols, etc., everything had chlorofluorocarbons. Now this is when they realized that chlorofluorocarbons need to go out of the picture. We need to stop using chlorofluorocarbons because of all the ill effects that it has, and this is when some steps were taken, and ultimately chlorofluorocarbons, you will see that, are not being used as much as they were used at that point of time. But nevertheless, because of this, we suffered a huge loss, and this loss is something that will take years to repair. So what ultimately happened was that a hole was formed in the ozone layer, and this hole is something which is called as ozone hole, which brings all the ultraviolet rays from the sun to the surface of the earth because there is no layer to protect the earth from ultraviolet rays of the sun. And this is where the problems start. So what you see in the pictures here is that the chlorofluorocarbons are emitted and they reach the ozone layer, and once they reach the ozone layer, the reactions will start, and because of the reactions the ozone will convert into oxygen, and because of the conversion of ozone into oxygen there will be a kind of hole that will be made, and because of this hole that has been made, the ultraviolet rays of the sun can now directly reach the surface of the earth. And this is the problem that we are facing. So when we talk about chlorofluorocarbons, these are compounds formed by chlorine, fluorine and carbon. That's why chlorofluorocarbon. They are often used as refrigerants, solvents and for manufacture of spongy plastics. Also, as we discussed, in air conditioners. So when these chemicals reached the Earth's stratosphere, they reacted with the ultraviolet radiation, which caused them to break down and release chlorine into the atmosphere. So since the chlorine was released into the ozone layer of the earth, it started to react with ozone, and we just saw the reactions 5 minutes back, how chlorine and ozone would react, and ultimately you get an atom of chlorine and you get oxygen. Now what happens is you get an atom of chlorine. Chlorine remains there, and because chlorine remains there, ultimately what keeps on happening is that this chlorine will remain in the atmosphere, will remain in the stratosphere for a very long time. And since it remains for a very long time, it will react with a lot of atoms of ozone. And because of that, for years, this kind of depletion will keep on happening. So what we will see is that a very small quantity of chlorofluorocarbons will be able to deplete a very large quantity of ozone in the stratosphere. And this is something that was observed, as I said, in 1970s. And after that, we have seen very deteriorating effects of this on the ozone layer. Although we have seen in the past few years that ozone layer has started to heal, but the entire healing process will take a lot of time. In April 2020, for example, there was one news article, one research that had happened, and there we saw that one particular hole in the North Pole ultimately has closed. But the closing of the entire ozone hole that has been caused by these chlorofluorocarbons will take up to at least one more century perhaps, and maybe another 80 to 100 years for it to completely heal. So this is the devastating effect of chlorofluorocarbons on ozone layer. So the thing is that when we say that it was unreactive, that being unreactive became one of the reasons that it became so devastating for the ozone layer. Because it was unreactive, it could remain in the atmosphere for a very long time and ultimately reach the stratosphere, react with ozone and cause all the problems that we are looking at. So this is about chlorofluorocarbons. So when we talk about chlorofluorocarbons, these are, you have carbon, you have chlorine and you have fluorine. So structure could be something like this, or the structure could be something like this as well. So ultimately the problem is chlorine that you have. Now this brings me to the next compound, and that is hydrochlorofluorocarbons. Now when we talk about hydrochlorofluorocarbons, these are compounds which are less harmful for the ozone layer as compared to the normal chlorofluorocarbons. And the reason behind it is that when we look at the structure here, one chlorine atom gets replaced with hydrogen. So it will be something like this, or it will be something like this. So what is happening is that at least one chlorine has now been replaced with hydrogen. So because of this replacement that has happened, it will have lesser impact on ozone layer. I'm not saying that it will not have an impact on ozone layer, it will have an impact, but the impact will be lesser as compared to the impact of a normal chlorofluorocarbon. So these are hydrogen chlorofluorocarbons, right? So there are 4 elements here: hydrogen, chlorine, fluorine and carbon. They are being used as substitutes for CFC because many of their properties are similar and they are less harmful for ozone. They have shorter half-life and they release fewer chlorine atoms because there are fewer chlorine atoms here. So this is hydrochlorofluorocarbons. Less impact but we cannot say that it does not have any impact. It does have an impact. After this, you have halons. So halons are compounds which are formed by bromine, fluorine and carbon. Now when we talk about halons, halons are something which are not very significantly used, not as much as chlorofluorocarbons or hydrochlorofluorocarbons, but there are special kinds of fire extinguishers where they are used. Problem is bromine. When it comes to bromine, bromine is much more reactive as compared to chlorine. Now, you might have read about this in the periodic properties of elements, that as you go down in a column, the reactivity increases. And if you look at the group number 17, in group number 17 you have fluorine, you have chlorine and then you have bromine. So that's why bromine will be more reactive as compared to fluorine or chlorine. So that's why, because halons have bromine, they are much more reactive, react much faster as compared to chlorofluorocarbons. Although since they have very limited application, that's why they are not found in as huge quantities as we find hydrochlorofluorocarbons or chlorofluorocarbons. So they are compounds formed by bromine, fluorine and carbon. Because of their ability to put out fires, they are used in fire extinguishers, although their manufacture and use is prohibited in many countries because of ozone depleting action. Their ability to harm the ozone layer is very high because they contain bromine, which is much more effective atom in destroying ozone as compared to chlorine. Why? Because bromine is more reactive. So it will react quicker and it will react faster. Then we also have methyl bromide, very effective pesticide that is used to fumigate soils and in many crops. Given its content in bromine, it damages the ozone layer as well. So one more compound that you can keep the name in mind of, that is methyl bromide. Then after that, you also have carbon tetrachloride. Now when we discuss about carbon tetrachloride, as the name itself suggests, it has one carbon and it has 4 chlorine. So because of this, you can say that again this is more harmful as compared to chlorofluorocarbons, because chlorofluorocarbons at least has one fluorine atom. Fluorine is less reactive. Fluorine being less reactive will be less harmful for the ozone layer. When it comes to carbon tetrachloride, again it will be more harmful for the ozone layer because there is an extra atom of chlorine that is present here. So it is a compound that has been widely used as a raw material in many industries, for example to manufacture CFCs and as a solvent. It is no longer being used as solvent because it was found to be carcinogenic, causing cancer. It is also used as a catalyst in certain processes where chlorine ions need to be released. So wherever there is a requirement of chlorine, we see that normally as a catalyst carbon tetrachloride is used, and because of these kind of reactions also carbon tetrachloride is also harmful for the ozone layer. So just try to remember the names of all these different families of compounds that we discussed. You have chlorofluorocarbons. Chlorofluorocarbons are harmful and they are the ones which were first discovered to be detrimental to the ozone layer. Then after that you have hydrochlorofluorocarbons, which have lesser impact on ozone layer, but at the same time what you should remember is that hydrochlorofluorocarbons are greenhouse gases, and because of that reason they have other impacts. Then after that you have carbon tetrachlorides, you have halons. All these will be important from examination perspective, especially prelims exam. So just remember these families, these names. The science behind it remains important and we discuss that part as well. Now after that we need to understand what is the impact of this ozone layer depletion. Now let's try to understand the problem. When we talk about the ozone layer depletion and we are talking about the causes of ozone layer depletion, there is one reason that we are worried. And the reason why we are worried is ultraviolet rays of the sun. So when you talk about the sun, from the sun to the earth, a large amount of ultraviolet rays are incident. But what happens is there is the ozone layer, and this ozone layer is able to shield us against the ultraviolet rays, something that could be harmful for us. Now since this layer is at the heart of the problem, what would mean is if let's say there is no ozone layer, then in the absence of the ozone layer, these ultraviolet rays will be able to penetrate through the atmosphere of the earth and will reach the surface of the earth very easily. Now when we talk about these ultraviolet rays, you have to understand that there are three kinds of ultraviolet rays. You have UVA, UVB and UVC. Ultraviolet rays A, B and C. Now when it comes to ultraviolet rays A, they are able to penetrate through the atmosphere very easily and reach the surface of the earth. But they don't cause any problems as such unless you have been exposed to ultraviolet rays A for a very prolonged period of time. So that's why UVA is not problem. Even for tanning purposes, etc., it is being used by many. So ultraviolet ray A is not a problem. Problem starts with B and C. So what happens is ultraviolet rays B and ultraviolet rays C, these are completely absorbed by the atmosphere. With the help of the ozone layer, ultraviolet rays B get completely absorbed, and with the help of ozone and with some reaction with oxygen as well, ultraviolet rays C also are completely absorbed. So because of that, what happens is the ones which could be harmful, the kinds of ultraviolet rays which could be harmful, they do not reach the surface of the earth. But now that there is a depletion of ozone layer that is happening, because of the depletion of ozone layer, now this ultraviolet rays B and C will also be able to penetrate through the atmosphere and reach the surface of the earth. And this is where the problem begins. So if we look at all the basic kinds of problems that we'll have to face if ozone layer depletion becomes a big problem, then it could be summarized like this. First could be in terms of what will happen on human health. So if we talk about the effect on human health, the first thing would be skin cancer. Why skin cancer? Because what has been observed is that the most common type of skin cancer, that is non-melanoma, is the cause of exposures to UVB radiation for several years. So if there is a prolonged exposure to UVB, then in that case you might have a chance to get affected with skin cancer. This is one. And there has been a report that has been brought out by UNEP, or United Nations Environment Program. It has predicted that at an annual rate of 10%, the ozone layer loss over several decades, there will be more than 250,000 cases per annum of just skin cancer because of UVB rays. So this is one problem. Then after that, there's another problem, and that is with respect to immune system. What has been also observed is prolonged exposure to UVB has a negative impact on our immune system as well. And because of that, we will now get exposed to multiple diseases. So prolonged exposure to UVB rays could be detrimental not only to skin but also to the immune system of our body, because our immune system will start to tolerate these diseases, and ultimately the vaccination programs, etc., that we are having will not be effective at all. So if you look at a long term period, this can be a very huge problem for humanity. So this is with respect to human health. Then after that, there is another problem that we can think of, and that is the effect on aquatic ecosystems. Now what has been observed is that phytoplanktons have a direct relation to UVB. If there is a prolonged exposure to UVB rays, the phytoplanktons in the aquatic ecosystems start to die. And because of that, the entire ecosystem, the entire food chain will also get exposed. Because of that, we'll see that there will be multiple issues which will start to arise in these kind of ecosystems. Now, because phytoplanktons are not there, the species which are dependent on phytoplanktons for their food and their livelihood, they will be also under pressure. And because of that, we'll see that ultimately there will be a destruction of the aquatic ecosystem that will be observed. Now, one of the reports of UNEP also says that if there is a, let's say, 16% decrease in ozone layer, or the amount of ozone in the stratosphere, in that case, we'll see that approximately 5% decline in the phytoplankton population will be observed. Because of this drop in population of phytoplanktons, we might lose approximately 7 million tons of fish per annum. 7 million tons of fish per annum. So just think of the entire ecosystem, how it will get affected negatively. And apart from that, not only that, how our economies will also get affected because of this depletion of ozone layer. So this is the second effect. Then the third effect we can think of in case of terrestrial ecosystem, one with animals and one with plants. Now in case of animals, again the problem is the same as humans, and that is skin cancer. Now what has been observed in many of the researches is that whether you talk about goats, you talk about cat, you talk about dogs, you talk about sheep, all these have been animals which get affected with skin cancer if they are exposed to UVB for a very long period of time. So they will also have the same effect as humans, and they will also get negatively affected with ultraviolet rays. Now we can also talk about plants. What has been observed in case of plants is that they negatively affect the growth and development of the plants. The shape of the plants start to change. Apart from that, we say that they damage the growth of the plant, they reduce the tree growth, change flowering times, make plants more vulnerable to diseases, and produce toxic substances. So all these are the effects that can be observed on plants if they are exposed to ultraviolet rays for a very long time. So this is another issue that we can think of. So in case of ultraviolet rays, first of all, you have to think of human health, you have to think about the aquatic ecosystem, and you have to think of the terrestrial ecosystem. And this is something that can maybe asked as a direct question, that recently ozone layer depletion and the things related to it, the developments related to it have been in news. What could be the negative effects of depletion of ozone layer or something that we call as ozone hole? So this can be a direct question either in the prelims, where they can give you 4-5 reasons, 4-5 statements, and ask which of the following are correct or not, or it can also come as a direct question, one of the parts of the question in the mains examination as well. So you have to understand these two aspects of ozone layer depletion. So first we discussed causes, and now we discuss all the consequences.